Welcome back to Arxflix. Today, we're diving into an innovative paper titled Toon3D, Seeing Cartoons from a New Perspective. This research addresses the challenge of recovering the underlying 3D structure of hand-drawn cartoon scenes, which are often geometrically inconsistent. Here's a snapshot illustrating how Toon3D reconstructs a consistent 3D model from geometrically inconsistent cartoon images. Let's break down the main points of this paper. Hand-drawn cartoons are usually not geometrically consistent. Artists draw new images of scenes without 3D rendering engines, making consistent perspectives challenging to achieve. Traditional structure from motion pipelines fail here because the images don't fit physically plausible camera models or consistent geometry. Here's an example of geometric inconsistencies in cartoons. The arrows in this figure illustrate how difficult it is for humans to maintain consistency across different perspectives. The Toon3D pipeline is composed of three main steps: sparse alignment, dense alignment, and Gaussian refinement. Sparse alignment involves taking a set of correspondences and back-projecting them into 3D using predicted depth maps. Dense alignment refines the camera parameters and aligns the dense structure by deforming vertices until achieving near-perfect alignment. Gaussian refinement uses the densely aligned point cloud to create a more immersive visual experience than point clouds or meshes alone. Here's an overview of the Toon3D framework. You can see how it starts with labeled points and masks, recovers camera poses, and finally aligns a dense point cloud for visualization. Toon3D also introduces an annotation tool called Toon3 Labeler. This web-based tool allows users to label points and segment transient objects in images. It's especially useful for scenes where automated methods like Solomapap fail due to inconsistencies. Here are some screenshots from the Toon3 Labeler. It's a user-friendly tool with no installation required, fitting nicely into a human-in-the-loop process for 3D reconstruction. Now, let's dive into the method. Toon3 starts with sparse alignment, using human-annotated correspondences that are back-projected into 3D with predicted depth. This equation shows how points are back-projected. Next, the dense alignment step optimizes these parameters and warps images to better align the dense structure. Various regularizers ensure that the warping preserves the overall structure and appearance. After alignment, the final step is Gaussian refinement. This stage takes the aligned depth maps and produces a dense 3D point cloud that can be visualized from multiple perspectives, adding an immersive element. Here's an example of 3D reconstructions of cartoon scenes, showcasing the detailed results Toon3 can achieve. The paper evaluates Toon3 both quantitatively and qualitatively. They show that Toon3 can achieve better camera poses and 3D reconstructions compared to traditional methods, even highlighting geometric inconsistencies in the original drawings. The figure depicts qualitative results, showing how different regularizations impact the accuracy and visual quality of the reconstructions. Interestingly, Toon3 isn't just for cartoons. The method also proves effective for reconstructing sparse photo collections, like urban brooms and even paintings. Here's an example of reconstructing the Trevi fountain from multiple paintings, demonstrating Toon3 versatility. Toon3 offers a robust framework to recover and visualize 3D structures from geometrically inconsistent hand-drawn images. The user-friendly Toon3 Labeler makes the process accessible for artists and researchers alike. For a more immersive experience, check out their project page at Toon3 Studio. Hope you enjoyed this summary. Don't forget to like, subscribe, and hit the bell icon for more updates from Arxflix. See you next time. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.